Hello, Advanced Geometry students. It's Mr. Donaldson here, and today we're going to start the first unit of actual geometry. I know we've been doing a little bit of algebra review so far and working with quadratics, but today we're going to get into the three building blocks of geometry. Now, as these are the first three terms in our geometric language, we technically cannot define them. However, we can use these three undefined terms to define all other terms in geometry. And again, as I mentioned in class, we've got to start somewhere. So these are our first three words in our language of geometry. So they don't really have a true definition because we don't have other words in our geometric language to define them with. So what we can do, the best we can do, is just describe them and kind of have an understanding of what they are and what they mean. So the first thing is a point. And as some of you put in your little small group discussion the other day when you filled it in and you tried to describe for me a point, a lot of you did a pretty good job. A lot of people told me that it represents a location. And some of you said it was a dot. And I believe one group even went to say it had no size. Nice work. So that is exactly what a point is. Just as a location in space. And if you look around you in your room right now, there's an infinite number of points surrounding you. And the way we represent those is with a little dot. So here is point H. And the reason we give it that little letter there, that H, is we can name it. So you know which point I'm talking about. I can refer to it. And so the way we name it as point H. Now one thing I want to point out is a common mistake is students like to write, oh, it's called point H. But in actuality, you don't need to write that word point because in geometry, a capital letter means point. So really, if I were going to read this, it would say point H, which is a bit redundant. So just one capital letter is sufficient for you to name a point for me. Then we move into a line. A line contains an infinite number of points. It extends infinitely in opposite directions. It has no width, and it is one-dimensional. Here is a line. And where this part where it says it's an infinite number of points, if you can imagine that between any 2 points on this line, if you were to zoom in, there's more and more and more points. There's an infinite number there. Now, there's multiple ways you can name a line. And the first is by just using any 2 points on that line. So I could call this line AC or line AB or line CB because as soon as I identify 2 points on that line, it would be implied that it contained the third one by this diagram. So for instance, if I say, hey, I'm going to call this line AB. And when you're naming a line, you got to put a little line with arrows over the top of it. All right? Another name I could give this line is I could call it CB. And it's the exact same line because when I go and look at this diagram, I'm like, okay, which line goes through A and B? Well, it's the same one that goes through C and B. So it just doesn't matter which point you pick as long as you just pick 2 on the line. And the order doesn't matter. Line BA, same thing as line AB. There's also sometimes a little small lowercase cursive letter next to a line, and that is a shortcut for you to name it. So you could also call this line M. Now, in geometry, a lowercase cursive letter is intended to imply that you're talking about a line, but sometimes your textbook is a little bit inconsistent with this. So sometimes when they're using a lowercase cursive N, they'll actually write the word line. And that's okay to do that. All right, and then finally, a plane. And a lot of you said this in your little group discussion the other day, that you thought a plane was a flat surface. And it is. It's a flat surface. Now, one thing you got to understand is that it never ends. Now, with a line, the way I can indicate that it never ends is by putting arrows on the end. I can't stick arrows all around this plane. I wouldn't know where to stop putting arrows. So, whenever you see, a little representation of a plane like you see here, it is implied that it continues forever. And of course, I couldn't draw something that continues forever. You just have to have that understanding that planes go on forever. Now, when you're naming a plane, this is important, you're going to use 3 non-collinear points. Now, I'm going to define this word for you. We're going to write it down on the next slide. But non-collinear simply means not in the same line. Okay? So, and there's a reason for that. If you were going to name this plane and you said, hey, I'm going to call it plane EFG. Well, you know what? There's a vertical plane that's not drawn but exists that goes right through those points E, F, and G as well. So because of that fact, because multiple planes can go through one line, you got to name a plane with non-collinear points. Okay? So that means just pick any 3 points on that plane that are not in a straight line. So I'm going to use points, how about D, E, and G? And when you write three letters next to each other with no commas and no other symbols, it is implied in geometry that you're referring to a plane. So when I just look at that, what maybe before this class you would have read as DEG, I know in geometry that says, hey, that's plane DEG. And I know my E is terrible, so I'm going to rewrite that one. So this is plane DEG. Or you could call it plane, it doesn't matter, just 3 points not in a line. How about plane IJH? And then just like with this little M with the line, sometimes a plane will have like a big, and this is supposed to be cursive, a big cursive letter in the little corner of it that's not next to a point. You'll notice that this W is not near any identified points. So that means that we're trying to name this plane just plane W. So you could also call it by a little cursive letter that you would see in the corner sometimes, plane W. So there you go. Those are point, line, and plane. And remember, these aren't definitions. We just kind of describe them. Now we understand how to name them as well. All right, so next, a couple definitions. So now that we understand the three undefined terms of geometry, we can use these terms to define others. In addition to introducing definitions and notes, there is also a running glossary on the Schoology page for your convenience. So keep that in mind. If you're reading a word in a problem in homework and you're like, man, I don't remember what that word is. Well, there's a glossary on your Schoology page where we'll keep track of all the definitions we learn. And the reason for that is because the textbook doesn't do a very good job of giving all the definitions. So Ms. Butler and I will do that for you. All right. So collinear, if we break this word up and think about it, co means same, like for instance, co-ed, like a co-ed dorm, you know, boys and girls living in the same dorm. Co-workers, workers at the same place. So co is same. Linear, as you remember from algebra, is line. So collinear just means on the same line. Now in my diagrams here, just to save some time for this video, I went ahead and put some lines and planes here. So if I wanted to give you an example of collinear points, for instance, I could put points A, B, and C on the same line, and they are collinear. And one other thing to point out is any 2 points are always collinear. And the reason for that is if you think about, if I draw 2 points anywhere on this screen, let's say I put a point here, and I put a point here. Well, there's always a line that will connect those 2 points. Always. Okay? So any 2 points will always be collinear, even if there isn't a point drawn in a even if there isn't a line drawn in a diagram. 2 points, always collinear, because you could always draw a line through them. Non-collinear means not on the same line. So for instance, if I put point X and Y on this line, and then put Z somewhere not on it, then those 3 points together will be referred to as non-collinear, because they're not all 3 on the same line. Now, are X and Y collinear? Absolutely. Any 2 points are collinear. You can see they're on the same line. Are X and Z collinear? Absolutely, because any 2 points are collinear. I could draw a line right through them. But those 3 together are non-collinear because all 3 of them are not on the same line. Coplanar. Think about this word again. Co means same, planar, plane, on the same plane. So if I put 3 points, how about A, B, and C, those 3 points are all on that plane that's drawn, so they are coplanar. And here it says any 3 points are always coplanar. And the reason for that is you got to really think three-dimensionally. Maybe I'll try to show you a demonstration in class on my web camera. But if you think about like a 3-legged stool, it would never wobble. Okay? So let me just draw my little stool here. Got a leg, got a leg, got a leg. Here's the ground. That stool would never wobble. These 3 legs would all hit the ground. Maybe it would be leaning or something, but they would all hit the ground. If you take 3 fingers and spread them out so they're not all in a straight line and touch them against your desk, you'll notice they all hit that plane. So any 3 points, always coplanar. Keep that in mind. That is important. On an assessment, I'll ask you, hey, are points X, Y, and Z coplanar? And you always would answer without even looking at the diagram, yes, because any 3 always have to be. Non-coplanar. Non-coplanar means not on the same plane. So if I put points A, ooh, that was a bad A. Let me try that again. Come on, undo. Let's try that again. All right, here we go. If I put point, let's put A in the corner here, make my life easier. All right, and then point B here, and point C here. All right, now right now those 3 points are all coplanar. All right, and if I put D somewhere just not on that plane, so those 3 points define that flat surface, and then D is just floating down here beneath it, those 4 points are non-coplanar because they're not all on the same plane. Sweet. All right, so just let's do a couple examples here. But how about before we do those examples, it'd be great if you guys could pause the video right now and maybe try to do them yourselves. And then come hit play when you're done and just kind of see if you're on the right track. Okay, I hope you paused it and tried it yourself, but welcome back. So let's just answer these questions. What's another name for line BG? All right, well, let's find line BG. Here's B and here's G. Now you may be thinking to yourself, well, it's not a line. It doesn't continue forever. There aren't arrows on the end of it, like for instance line T has. But remember what I told you, any plane extends forever. So if I have these 2 points that are on a plane, it is implied that that line that contains them is also extending forever. So if I want another name for line BG, I just need any 2 points that are on it, other than B than G. So I could call it line GB, I can call it line BE or EG. You have a lot of choices. You just need another combination of 2 letters in a different order than B and G of points that are on that line. So how about line E, B, and definitely if I'm naming a line, I put a line with arrows on top. What is another name for plane P? Well, you can see the little P here in the corner. So this vertical plane is plane P, and remember the rules for naming a plane. You want 3 non-collinear points, so 3 points not in a straight line. So I'm going to go with C, F, and I. Those are 3 points on that plane that are not all in a straight line. They're not all collinear. They're non-collinear. So it's plane C, F, and I said I originally, but I was writing E, so we'll keep it there because that works as well. Plane CFE defines that plane. What is another name for for line T? Well, here's line T. It's another name for it. Well, I just need any 2 points on that line with an arrow on top. So let's call it line MK, for instance. That works. Arrow on top. All right, name 3 collinear points. Collinear, right? Points in the same line. So I'm just going to pick any 3. How about points A, F, and H? Now, when you're listing points or name, like if you're going to name your 3 best friends, it'd be like Bob, comma, Sam, comma, and Tim, right? So when you're naming 3 collinear points, do that. Because if you didn't put commas between them and you just put 3 points, A, F, and H, right next to each other, without commas or an and or something, I would think you were talking about a plane. So when you're listing, list with commas, okay? That's important. This tells me, hey, those are individual points that they're listing. Are points A, B, E, and H coplanar? Let's take a look. A, B, E, and H. Are they coplanar? Are they all on the same plane? Well, notice A, B, E, and H are all on this light blue horizontal plane. So yes, absolutely. Are points A, B, and C coplanar? I'm not even going to look at the picture. Of course they are. Any 3 points are always coplanar. But also you guys could imagine that there's some diagonal plane that's drawn, or not drawn rather, that contains those 3 points. So you can see why that would be the case. All right. And then, let's see if I can undo those. And last, or 2 more. Name 3 non-collinear points. I just want 3 points that are not all on the same line. So I'm going to start with 2 points that are on the same line. How about like K and M? And then I'm just going to pick any old point that is not on the same line as K and M. How about B over here? And again, I'm listing this time. Okay? All right. And then finally, how many points are in this diagram? You could go and be like, well, there's 1, there's 2, there's 3. But why would you do that? You know there's an infinite number of points because even in this line, there's an infinite number of points. So just be smart about it. There is an infinite number of points in this diagram. All right, guys, that is your first lesson in geometry. A little bit of vocab. Hope it made sense. Let us know if you have any questions when you're doing your assignment. See ya.